Hello everyone, this is the first lesson recording for IM1, September 25th, 2020. Apart from everything you normally need, I would like you to have your tile growth work from last class ready because we are going to revisit it today and I want it to be accessible. A few announcements. There is no school on Monday. Yay! That means you get a long weekend, and the A day that we usually meet on Mondays is going to become Tuesday. So Tuesday is our A day. That means you go to your period 1, 2, and 3. And Wednesday is our B day, and you go to period 4, 5, and 6. Thursday and Friday, you are just going to go to your outreach classes. Okay, whichever one that is, you're going to go to your outreach classes in a designated time, and so that they can take attendance for you then. And another important information is that next Wednesday when we meet again, you're going to have the quiz number 3 on exponent simplification. So we've been working on exponents a lot, okay, for the last 2-3 weeks. So if you're still unsure, then you need to come see me so that we can figure out what you are unsure about. Great. So this is where the class are going to meet and greet their new team. And if you're watching this video, it does not apply to you. So I'm going to move on. What are we covering today? We are going to be simplifying exponents further, and we're going to fill out our exponent rule graphic organizer that summarizes all the things that we've kind of figured out already, as well as explore the negative and zero exponents. And also we're going to revisit the tile growth, the linear functions. So to begin, I would like you to take notes on this. We're going to define, well, I talk a lot in exponents, okay? But I would like you to understand the different notation. So the parts of exponent expression. When you see 2 to the power of 4, what does that mean? That means 2 is being multiplied to itself 4 times. So that becomes 2 times 2 times 2 times 2. Well, we know that, okay? We call this number 2, the number that gets multiplied, we call that number base. And we call this number that tells us how many times that number 2 is getting multiplied to itself, we call that number exponent. Okay? So when you hear me talking about base, we're talking about the number that is being multiplied. And then when you hear me talk about exponents, or when you're using the word exponents, I hope you're referring to the number that tells you how many times that base is being multiplied to itself. Okay, and then together 2 to the power of 4, we say that is a power expression, and this 2 to the power of 4 is read as 2 to the power of 4, or sometimes it is read as 2 raised to the 4th power. They mean the same thing. Okay. Alright, so we are going to fill out this graphic organizer that summarizes many of the things that we've learned, as well as learn some shortcuts. If you have access to a printer, please print this document out. If not, that's not a problem. You just need to write your notes in your notebook. So this is a close-up view of the top 2 rows of the graphic organizer, and I am going to use my document. Okay, so this is the first 2 rows. So let's talk about x squared multiply x to the power of 3. We've been dealing with this a lot. Okay, so the x squared just means x times x, right? And we know that x to the power of 3 just means x times x times x. Okay. Okay, I zoomed in a little bit so that you can see better. Okay, but now we can say, okay, x is just being multiplied to itself. It doesn't really matter whether the x came from the first term or the second term. X is just being multiplied to itself how many times? 1, 2, 3, 4, 5 times. So we can rewrite this as x to the power of 5. But let's look at this, okay? This 5 comes from the fact that we're adding 2 from here. That tells me the 2 from here. And then 3 times that x is being multiplied to itself, that comes from this information here. So instead of always expanding it up, we can maybe rewrite this x to the power of 5 as x to the power of 2 plus 3. Okay, so we don't want to be expanding this every single time. Okay, we want to be able to come up with some shortcut that's going to work for every single case. And the beauty of using a variable instead of just some number like 2 squared multiplied by 2 to the power of 3 is that x can be any number. It does not matter whether it's a big number, small number, a decimal, fraction, or whatever. This rule will apply every single time. So this rule tells me that when the base, remember the base is the number that is being multiplied. When the bases are the same and we're multiplying one exponent expression to another exponent expression, then we can, instead of expanding it out, we can just add the exponents. The two numbers at the top, we can just add 2 plus 3 to get to 5, and that's what we did. So in generalized form, we can write this as x to the power of m, and m multiplied by x to the power of n. Okay, remember the basis has to be the same. The number that is being multiplied to itself, the bottom number, has to be the same in order for this rule to work. And when we are multiplying this expression to this expression, we can just write this is same as x to the power of m plus n. Okay, m plus n. And we will write some word explanation for this when we go back to our slides. And this is called product rule. Okay, why is it called product rule? Because we are multiplying one exponent to another exponent, and they both happen to have the same base. So we call that rule product rule. Let's do some examples. This is x to the power of 3 times x to the power of 8. Yes, we can expand this out and write out our x times x times x times x times x times x 8 times. Okay, but we don't want to do that. We know what is going to happen is this is going to be same as x to the power of 3 plus 8, which is indeed x to the power of 11. Okay, what about this? 2 to the power of 4 multiplied by 2 to the power of 3. The bases are the same. The number that is being multiplied, the bases are the same. So therefore, and we're being multiplying these two, so we can, this becomes 2 to the power of 4 plus 3, which is same as 2 to the power of 7. The next example, x squared times y times 3, x to the power of 3, y to the power of 4. Okay, in this case, we have two different variables, right? Remember, the bases have to be the same, but between all of this, it's all multiplication, 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 multiplication. So we are indeed multiplying, but we can only combine when the bases are the same. So we can combine x squared and x cubed. We can multiply those, and that becomes x to the power of 2 plus 3. And then to that, we can deal with the y. You have y is just really same as y to the power of 1. So y to the power of 1 times y to the power of 4 is really same as 1 plus 4. So that becomes x to the power of 5. 2 plus 3 is 5, multiplied by y to the power of 5 also. And that's the final answer. Okay? All right. Then what about the quotient rule? We explored that last class. Okay, so you started seeing that x to the power of 5 divided by x to the power of 3. Well, this is really same as x times x times x times x times x, right? Divided by x multiplied to itself 3 times. And we did decide that, okay, well, this is, we can form giant ones here. This just becomes, cancels out to be 1, cancels out to be 1, cancels out to be 1. You just need to match the numerator x with the denominator x, and they become 1. Okay, so what are we left with after we cancel out all these 1s? You're still left with 2 x's. That means we still have x squared as our final answer. However, Okay, instead of now we are dividing. Before we were multiplying just above, we are dividing. Dividing and multiplication, they are very, very related. Okay, so instead of adding, look what happened. If I just subtract 5, take away 3, that gets you 2, doesn't it? Okay, and that's because you get to match up however many is at the bottom with however many is at the top, and what you're left with is the answer that you have. Okay, so this just becomes same as x to the power of 5 minus 3. Okay, and in a generalized form, if we have x to the power of m divided by x to the power of n, okay, this just becomes x to the power of m minus n. Compare this to the previous one. We added when we are multiplying, but when we are dividing, that fraction line means division, we are subtracting m minus n, and to get this. And again, make sure when you're doing this, the bases are the same. Okay, if it's 2, if x is 2, then this has to be 2, 2. It cannot be 5 squared divided by 2 squared. That does not work. All right. All right, so we are going to do some write up here. I will ask you to leave the space here. And this is called the quotient rule. Why? Because when we're talking about quotient rule, we are talking about a fraction. We're talking about division. That's what we mean by quotient rule. Let's do some examples here. 6 to the power of 7 divided by 6 to the power of 4. Yes, we can write all of it out, but we're getting smarter now. We can use this rule, and we can say this is same as 6 to the power of 7 minus 4, because I know that 6 multiplied to itself 4 times is going to cancel out to 4 of the 6's here. Okay, so 6 to the power of 7 minus 4, which is 6 to the power of 3. This time we're dealing with variable. It does not matter. As long as the base is the same, we can still apply the same rule. This is going to be y to the power of 12 minus 5. So the number at the top, the numerator exponent, take away the denominator exponent. So that's y to the power of 12 minus 5 is 7. Okay, and then the last question is 9 times x to the power of 4 divided by 12 times x. And let's see, we can deal with numbers and x's, the variables with variables. Okay, so we can, when you see 9, we can, so let's separate this. This becomes 9 over 12, and we have x, multiplying that by x to the power of 4, and this is x is just really same as x to the power of 1. X being multiplied to itself 1 time is x to the power of 1. So this becomes x to the power of 4 minus 1. And let's see if we can simplify this fraction, 9 over 12. Is there a common factor to both 9 and 12? Is there a number that is divisible by both 9 and 12? Yes, it's 3. So I can divide numerator by 3, denominator by 3, which leaves me with the simplified version of this is 9 divided by 3 is 3, and 12 divided by 3 is 4. Okay, whatever you do to the top, you have to do to the bottom. As long as you do both to top and bottom, then it's like multiplying by 1 or dividing by 1, which is still the same number. And you are multiplying that to x to the power of 4 minus 1 is x to the power of 3. And that's my final answer. Okay, so from previous document camera, we filled out all the top section. We've solved all the problems and we've written down this generalized rule. Okay, and this time I would like you to pause the video and copy down what does this rule really mean in plain English, and copy this down as well, please. And we will continue with the rest in the next lesson recording.